Another type of mosquito and another type of vector-borne disease. Sorry. This section is called a sudden emergence of West Nile virus associated illness. So this is spread by the Culex pipiens mosquito, whose distribution of the various species is shown here from this paper. So you can see that the mosquito is present to quite high latitudes, which means the virus has to be brought in from somewhere, and somehow the blood feeding by the mosquitoes then makes it a vector-borne disease, right? So obviously with the migration, people movement, this is quite what happened. The symptoms very quickly, it's another febrile fever-causing virus. You end up with swollen lymph glands, nausea or vomiting, muscle aches, joint pain, and so on. And the transmission cycle is complicated. I'm showing this again, even though it's just a schematic to say how hard it will be to actually track the impact of climate on the spread of West Nile and impact of climate on West Nile emergence, outcome, and so on and so forth. In nature, West Nile virus cycles between mosquitoes, especially Culex species, and birds. Some infected birds can develop high levels of the virus in their bloodstream, and mosquitoes can become infected by biting these infected birds. So birds carried it quite far. After about a week, infected mosquitoes can pass the virus to more birds when they bite. Mosquitoes with the West Nile virus also bite and infect people, horses, and other mammals. So they are called dead-end hosts or accidental hosts. And however, humans, horses, and other mammals are dead-end hosts. That means they do not develop high levels of virus in their bloodstream and cannot pass the virus to other biting mosquitoes. Okay, which is good news if you don't mind getting the virus. So here is a dead-end host, here is a dead-end host, and here are the amplifier hosts, because once they get infected, they allow the pathogen, the virus, to multiply quickly in their bloodstream, which are then picked up by mosquitoes, which bite the other birds, and then soon you have a cycle which increases the availability of West Nile virus as a reservoir among the birds, and then transmitted by vectors like the mosquitoes, Culex type, right? So here is the worldwide distribution of West Nile virus. There are different lineages. I won't go into the details, but again, you have to remember that each type of dengue we saw, there were 4 serotypes. This one has many lineages. There's one called Spanish lineage, Malaysian lineage. This is serological data only. We won't go into those sorts of details, but there are things that are endemic to India, multiple types here. So lineage 1 and 5 are present in India for whatever reason. We have to figure that out. Here, for example, in Central Africa, we have again types lineage 2 and 1, I think. Okay, obviously Spain has the Spanish type and Portuguese has a mix. Australia has lineage 1B, and so on and so forth. So these things matter because, again, climate change is going to be different in each of these places. Specific Culex species may be different, specific vegetations and habitats are different, so we have to really get a handle on all those things to understand climate impact on the net outcome on the West Nile virus. The seasonal cycle of West Nile virus in temperate North America begins in the spring when birds are nesting, thus providing a large number of susceptible avian hosts on which infectious Culex mosquitoes can feed. In the US now, this is the largest mosquito-borne disease. burden. Okay, so that's why we are so worried about it. Important amplifying hosts include members of the crow family, house sparrows, robins, and certain wading birds. So these birds, when they get really sick, can die. So whenever people see dead birds, they begin to panic that maybe West Nile virus is around. Individuals of bird species that develop a high level of virus in their blood following infection can act as amplifying hosts. It's kind of a bioamplification that we talked about for certain HABs, the toxins released by certain harmful algal blooms. For example, shellfish tend to amplify those. What is happening? Sorry about this. I don't know why it's doing this. Individual bird species, okay. As the number of bird hosts begin to decline, the Culex vectors start to shift their feeding activities to mammals in late summer and early fall. A fact that increases risk of the West Nile virus infection for humans and other mammalian mosquito hosts fed on by these mosquitoes. Okay. You get the idea. Temperature and precipitation are reported to be the strongest climatic predictors of regional transmission and human risk of West Nile virus. So basically the idea again is that as complicated as the life cycles are, and remembering the basic old adage that nature makes the rules in terms of setting the winds, the relative humidity, precipitation, temperature, and parameters that matter for the species life cycles and so on, and their ecology in the habitat they live in. What we are trying to do is look for loopholes. So the old adage, as I said, is nature makes the rules and biology finds the loopholes. So each species is trying to survive, and there are two ways of surviving. For example, the fish and birds and phytoplankton and so on that are heavily affected by El Nino, let's say in the Eastern Pacific, have evolved to respond to El Nino cycles which happen every few years and create a massive perturbation. So there is a lot of perturbation to the entire ecosystem, from phytoplankton, zooplankton, fish to birds, mammals, and so on when El Nino comes, but the whole system recovers. And that is different than trends or climate change, which keep changing in one direction. Warmer temperatures, more extreme rainfall, reduced rainfall, increased humidity, and so on. So we have to understand the difference between climate change impact on the ecology, life cycle, and even social political factors that go with the climate change versus climate perturbations like natural variability of El Nino, monsoon variability, and so on. Okay, so that's why it's much more complicated to understand disease ecology, but nonetheless these kind of empirical relations are always useful because they provide an engineering solution till the details are understood. So if you know that temperature increase leads to increased West Nile virus, maybe because people are more out in the regions where birds and mosquitoes are being in contact with humans, or whatever reason, then that can be used as a early warning system. Temperature relation with West Nile virus can be used as a early warning system, which can help a lot to bring down exposure and disease outcome. Okay, this is one of the key factors of dealing with planetary health as well.